Intermediate value theorem, also known as IVT. Okay, it's a very simple concept, and you might even wonder, like, why do we have to have it or even call it out as a theorem? But it is an important concept. So we have some function, okay, and we take some particular interval, okay, closed interval, meaning this is included, that is included. Okay, so what is this interval? The interval is a comma b, closed interval, meaning the endpoints are included. And this function f of x is continuous in this closed interval, meaning it is continuous at every point inside this interval. When x is a, what is the height? F of a. And what is this height? F of b. We have a function f of x which is continuous in a closed interval a to b. From a to b, there is no break in this function. So at a, the height is, or the value of the function is f of a, and at b, the value of the function is f of b. And I just drew one example. It doesn't matter. One can be bigger than the other. F of b could be smaller, or they could be equal, right? It could be anything. But I drew one picture here. Given this, the intermediate value theorem says every value between these 2 points, like here, between fa and fb included, will appear on this graph within this interval a to b. So let's see what that means. So let's say I pick any arbitrary value here between fa and fb, right? Because I'm saying every value appear here, so I can pick any value between fa and fb. Okay, and now I go back to the graph. One thing it is saying is that it will intersect the graph. It is guaranteed to intersect the graph. And when you look at its x value, it could intersect in multiple places, right? But at least there will be one of these values which will fall between a and b. Basically, it is saying there is no break, right? If there is a value here that is not present on this graph, that means somehow we started from f of a, and going through this interval, we jumped over some spot, that there was a spot that we did not cover. But then it will be broken. But f of x is continuous, so it cannot be broken. That's all the intermediate value theorem says. That every value between fa and fb will appear somewhere on this graph for an x value, which we show as c, which lies between a and b. So it's saying you pick any value between fa and fb on the y side, you're guaranteed to find a c, some value in between a and b, such that c comma fc is that particular value. C comma m is on the graph. It's guaranteed. If m is between these two, it's not possible that f won't be here, because then it's kind of a hole, right? But we already said f is continuous, so that's not possible. Okay, so let's look at how it can be useful. So suppose you have a function. It is continuous in some interval a comma b, right? So these are the conditions for IVT. And we know, let's say f of a is -3 and f of b is 5. So what does that mean? If I draw a picture, if I draw this graph, I don't know what this function is. All I know is that at a, this f of a is -3, correct? And at b, f of b is 5. Also, I know that f of x is continuous. That means from here to here, it is continuous. I don't know what the shape is, but it is continuous. What does it tell you that is not written out here? Just by looking at the graph, what new information do you have? Is it possible for this graph not to intersect the x-axis between a and b? Can you draw this continuous graph from -3 at A to 5 at B without crossing the x-axis? Not possible, right? Because it's continuous, right? You cannot have a break. And that's what intermediate value theorem is telling us. How? This is how it's telling us, right? So this is -3, right? And this is 5, right? So it is saying any value you take between -3 and 5. So I can take 0 because 0 is between -3 and 5. So IVT guarantees that 0 appears on this graph between A and B. Y equals 0 appears on this graph between A and B. This is guaranteed by IVT. So that tells us that there is at least one 0 of this function. You remember zeros or roots, the x-intercepts, right? So without even knowing anything more about the graph, just the IVT tells us that there is at least one place between A and B where it will intersect the x-axis, or there will be a 0. So this can be helpful in finding where are the zeros of a function, right? If I knew this information like this, I don't know the actual exact function, but I knew it was continuous, then I can say, oh, between A and B, there has to be a 0. A and B could be something, right? 2, 6, whatever. So this way, IVT can be helpful in identifying the zeros of a continuous function. Yeah, I don't know how many times it crosses. Maybe it crosses 2, 3 times, but at least one is guaranteed. Okay, use the intermediate value theorem to show that there is a 0 in the interval 0 to 1 for the function f of x equals x cubed plus 2x minus 1. So what is given? A closed interval is given, right? This was our A and B. And this function is given x cubed plus 2x minus 1, right? And they're telling us to use the IVT. So what more is required in order for us to use the IVT? This f of x has to be continuous, right? The IVT says that there is a continuous function over a closed interval, right? So if f of x is not continuous, then it's not going to work. So first thing we have to show is that f of x is continuous. So if this is a polynomial, and polynomials are continuous everywhere. All polynomials are continuous everywhere. There's no break in the polynomials, right? So now I can use the IVT because I have a closed interval and I have a polynomial which is continuous everywhere. So it is continuous over. So continuous everywhere. Okay. And how do we show that there is a 0 in the interval? For me to do intermediate value theorem, I have to find f of A, right? And f of B. So f of A is f of 0. What is f of 0? -1. F of B is f of 1. What is f of 1? 2. Now if you try to draw this graph, right? 0 and I'll put 1 here. At 0, it is -1. And at 1, it is 2. And it's a continuous graph on which these 2 points lie, correct? I don't know what the shape is, but something like this. Now you see why there has to be a 0. 0 means where y is 0 or f of x is 0. So first, because of this, we say IVT is applicable. As 0 lies between f0 and f1, by IVT, there exists C such that 0 is less than equal to C is less than equal to 1. So somewhere between 0 and 1, there is a C such that f of C equals 0. Well, here we don't have to find C because they're just saying show that there is a 0. So we don't need to find the C. Okay. If they say find C, then you find it. So we don't have to do that.